sets in Venn diagram form. This is set A consisting of element -1, 0, 1 and 2. And set B consists of elements -4, -2, 0 and 2. And a function f such that a to b is defined as fx is equal to x square minus x for all x belong to set A. And gx is defined as twice modulus x minus half minus 1, again x belong to A. So we have to prove, rather we have to check whether f equal to g or not. If f and g are two functions on the same set, then the two functions are said to be equal if fa equal to ga for all a lying in the given set A. That is, if each element A is associated to the same element under function g, fa equal to ga for all the elements in set A, then the two functions are said to be equal. Two functions are said to be equal if each element of set A is associated to an element of g under function f is same as that under g. So let me see with the help of Venn diagram, first of all, the correspondence under function f. What is the definition of f? Fx is defined as x square minus x. So what is f of minus 1? See, f of minus 1 will be minus 1 square, which is 1, and minus 1. So it will be what? 1 minus 1, that is f minus 1 will be, look at it again, f of minus 1 is minus 1 square is 1 minus, please make a correction, 1, okay, minus 1 square minus minus 1. So it is minus 1 square is 1 and minus plus 1. So it is 2. So minus 1 corresponds to 2. Okay. And then 0. 0 square is 0 minus 0. 0 corresponds to 0. 0 corresponds to 0. And then 1. 1 square is 1 minus 1, 0. 1 also corresponds to 0. Then what about 2? 2 square 4 minus 2. 2 corresponds to 2. 2 corresponds to 2. So this is the association. Let me write it in roster form. What are the elements of f? The elements of f are minus 1, 2, 0, 0, 1, 0, and 2, 2. Call it 1. This is your function f written like this. And now let us see function g, how the association takes place under g. Again from set A to B. What are the elements of set A? Are minus 1, 0, 1, 2. And what are the elements of set B? Minus 4, minus 2, 0 and 2. And how is the function defined? Gx is defined as, I write it again, twice modulus x minus half minus 1. Now what is g of minus 1? G of minus 1 will be twice minus 1 minus half modulus minus 1. Minus 1 minus half will be minus 3 by 2 minus 1. But modulus of minus 3 by 2 will be 3 by 2 minus 1. So it is, what is f of minus 1? It is 2. So f of minus 1, g of minus 1 is 2. We are finding the g image. G of minus 1 is 2. And now let's see g of 0. G image of element 0. So 0 minus half twice 0 minus half is minus half. 0 minus half is minus half, and as a modulus it will be half, and minus 1. So 1 minus 1, finally you get 0. So 0 corresponds to 0. 0 corresponds to 0. Then what about the next 1? So 1 minus half is half. Modulus of half is half. 2 into half. 2 into half is 1. And 1 minus 1 is 0. So you find that G image of 1 is also 0. Then 2. 2 minus half is 3 by 2. Modulus of 3 by 2 is 3 by 2. 2 into 3 by 2 is 3. 3 minus 1 is 2. So 2 corresponds to 2. Now write all these elements of G in roster form. It is minus 1, 2. Then you have 0, 0. And you have 1, 0. And also 2, 2. Now you compare the functions f and g. We find that all the elements of set f are exactly same as the elements of set G. Or in other words, we can say FA equal to GA for all A in the given set A, and hence the two sets f and g are, hence the two functions f and g are equal. The next question is, given is a set A consisting of elements 1, 2, 3, then number of relations containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. Okay. So now because we have to write a relation which is reflexive, the set A is given to be 1, 2, 3. So what are the elements of R? You know, because it has to be reflexive means 1, 1. Every element should be related to itself 1, 1, 2, 2, 3, 3 will be included. And he already says containing the elements 1, 2 and 1, 3. And he also says that the relation is symmetric. So as far as 1, 1, 2, 2, 3, 3 is concerned, that is not a problem. But if 1, 2 is there, then 2, 1 should also be there for the function to be symmetric. And likewise, if 1, 3 is there, then 3, 1 should also be included. 1, 3 is there, so 3, 1 should be there. So what are the elements in R? 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 1, 3, 3, 1. These are the elements. Now, it is reflexive. As such, it is this relation is reflexive and symmetric. But we have further to find out that it should not be transitive. It should not be transitive. So can I find a pair of elements here? For example, 2, 1. Look at these two elements, 2, 1 and 1, 3. 2, 1 belong to R and 1, 3 belongs to R. And for transitive, for relation to be transitive, A related to B, B related to C. 2 related to 1, 1 related to 3. So 2, 3 should belong to R. But we find that 2, 3 does not belong to R. 2, 3 does not belong to R. So the relation written over there is not transitive. And it can easily be seen that this is the only one relation which has been mentioned, which is reflexive and symmetric but not transitive, and containing the elements 1, 2 and 1, 3 on set 1, 2, 3. So there is only one possibility.